So in this lesson, we are going to look at binomial expansion. So first of all, we start by defining what is binomial expansion. So binomial expansion is an algebraic expression that contains two variables. In this case, we are talking of two unknowns, a simpler way of explaining what is a variable. For example, we may have x plus y. So x is a variable and y is a variable. So this is an algebraic expression with the two variables x and y, and thus it is a binomial expansion. Another example is 2a plus b into bracket squared. So that's also a binomial expansion. So a is a variable, b is a variable. Another example is m plus 2n into bracket cubed. So this is also a binomial expansion where m and n are the variables. So binomial expansion, we start by expanding binomial expansions up to power 4. We start with x plus y. This is a binomial expansion because it has two variables, but we cannot expand it any further. From there, we take another one, x plus y into bracket squared. We can expand this and say this is x plus y, then we have x plus y. So we multiply x multiplied by x, we will get x squared. X multiplied by y, we will have plus xy. Then y multiplied by x, we will get xy. And y multiplied by y, we get y squared. So we find that this and this are common, and therefore we can add them and say write our final expression as x squared plus 2xy plus y squared. So that is the expansion of that binomial. In our previous expansion, we have dealt with x plus y into bracket squared. So this time we will expand x plus y into bracket cubed. So this is equals to, it can be written as x plus y into bracket and x plus y into bracket squared, because when you multiply here we have 1. Remember the rules of indices. So we have already expanded this. So instead of expanding again, we just replace it. So we have x plus y into bracket. We found that when we expanded that, it is x squared plus 2xy plus y squared. So we only need now to expand here, multiply x multiplied by x squared, so that will give us x cubed. X multiplied by 2xy, that will give us plus 2x squared y. Then we multiply x multiplied by y squared, there we will get x y squared plus then we come to y multiplied by x squared, we will get y x squared plus y multiplied by 2xy, we will get 2xy squared, and finally we have plus y multiplied by y squared, we will get y cubed. From there, we look at what is common. So we have x cubed. I look at 2x squared y. Do we have another one? We have this one and this one. So we can add the two and we get plus, we will get 3x squared y. Then you can see this one and this one, they are common. So we have plus 3x y squared, and finally we have our y plus our y cubed. So this is the expansion that we get from what we have. So we have x plus y into bracket cubed. When you expand to the last step, this is what you should get. In our last expansion, we expanded a binomial whereby the index was 3. Now we will go ahead and expand an expansion, a binomial x plus y into bracket to power 4. So this can be written as x plus y into bracket, then x plus y into bracket cubed. We have already expanded this in when we had x index is equals to 3. So we can replace it here and say this is equals to x plus y. Our expansion was x to power 3 plus 3x squared y plus 3x y squared plus y index 3. So in this case, we need to multiply each and every term here by x. So we multiply x multiplied by x to power 3. We will get this is equals to x to power 4. Then we have x multiplied by 3x squared y. Then we will have 3x cubed y. X multiplied by 3xy squared, we will have plus 3x squared y squared. X multiplied by y cubed, we have x multiplied by y cubed plus, now we take over from y, so y multiplied by x cubed, we have x cubed y. Y multiplied by x, 3x squared y, we will get 3x squared y squared. Then we have y multiplied by 3x y squared, we will get 3x y cubed. Finally we have y multiplied by y cubed, we will get y to power 4. Now from there we look at the right terms that we have. So the right terms that we have, we don't have x power 4 apart from this one. So we write this is x to power 4, then plus 3x cubed y, and here we have 3x cubed. So when we add the two, we get 4x cubed y, and then we come to this one, we have another one here. So when you add 3x squared y squared, you get 6x squared y squared. We have xy cubed, and here we have xy cubed. So we have 4 of them. So we have 4xy cubed. And finally we have y to power 4. It's the only one. So we have y to power 4. So there we have now an expansion of this x plus y to power 4. When you expand it completely, this is what you get. So that is the expansion. Now we look at the expansions that we have had. We started with x plus y. In this case we assume it is to power 1, which we got the same x plus y. Then we came to the second one, x plus y into bracket squared. We got x squared plus 2xy plus y squared. We came to the third one, x plus y into bracket cubed. We got x cubed plus 3x squared y plus 3xy squared plus y cubed. Finally, we got x plus y into bracket to power 4. This we got x power 4 plus 4x y, x cubed y, plus 6x squared y squared plus 4x x power 1 y cubed, and finally we had y to power 4. From this pattern, we are going to note something that is happening here, which is going to help us to generate what we call a Pascal triangle. So we are going to consider some numbers. So if we can put 1 here, we know when you multiply 1 by x, it is still the same. So we also have 1 there. Here we can put 1. We call them the coefficient of x squared. Here we have 2, and here we have 1. Here we can put 1. Here we have 3. Here we have 3, and here we can put 1 there. So here we have 1. Here we have 4. Here we have 6, and here we have 4, and finally we have 1. If you look at this coefficient, they form kind of a triangle. So let's start with 1 up there. Then we take this 1 and 1, we get 1 there and another 1 there. Then we start with 1, we have 1, we have 2, we have 1. Then we have 1 again, we have 3, we have 3, we have 1. Then we have 1, 4, 6, 4, and the last 3 we have 1. So they form a triangle. They form a triangle. This one. These are the coefficient of our terms in our expansion. So we are going to discuss this triangle further and see how it helps us in general expansion of a binomial. We notice that when we expanded, let's say we start with x plus y and the power is 0. So anything to power 0, we get 1. Then we get x plus y to power 1. So this will remain like that. So the coefficient of x and y remains 1. When we expanded x plus y into bracket squared, we got the coefficient 1, 2, and 1. Then we have x plus y into bracket cubed. We got the coefficient 1, 3, 3, 1. And then we have x plus y is to power 4. We got 1, we got 4, we got 6, we got 4, and lastly 1. So these are the coefficients of our expansion. Now, looking at this pattern, we can discover something, that each row start with 1. So you can see each one start and ends with 1. Then we get the other numbers from 1. If you add 1 plus 1, we get 2. If you add 2, you add to 1, you get 3. If you add 1 here and you add to 2, you get 3. Here you add 1, you add 3, you get 4. We add 3 here, we get 6. We add 3, we add 1, we get 4. Meaning, with this pattern, we can be able to generate the next number. Since we are saying it starts with 1, then we can put 1 there. Then when you add 4 and 5, you should get 1 and 4, you get 5. You add 4 and 6, you get 10. You add 4 and 6, you get 10. 4 and 1, you get 5. So that, and we can continue like that on and on. And this is what we refer to as Pascal triangle. This is what we call Pascal triangle. So this pattern is called Pascal triangle, named after the Pascal, who was a mathematician and a philosopher, French mathematician, philosopher. In he lived in 1623 to 1662. So he was a mathematician who came up with this pattern. Then let's have a look at the way the powers are behaving. For us to see how the powers are behaving, I want to consider 2. Then you can look at the others on your own. So we have, for example, x plus y into bracket cubed. When we expanded, we had x cubed plus 3x squared y. Then you have plus 3x y squared plus y to power 3. Then we have x plus y into bracket to power 4. We got, this is x to power 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to power 4. Now, looking at our pattern here, we can see that from a Pascal triangle, we have seen that our expression or our expansion always start with 1 and end with 1. So you notice the index here. So the first term always take that index. That is 3. Now, look at the power of x. It is reducing. This one is 2, so it reduces by 1. This one is 1, so from 2 you got 1. And here maybe we can assume that it is x to power 0. So it is reducing from 3 up to 0. Look at the y. We can say here, if we put y to power 0, it is the same as 1, so it doesn't make any difference. So here we can say y to power 1, y increases to 2, and finally to 3. So you can see the terms of our variable, the power of one increases as the other one decreases. Look at this one. X take the power of our index here. So it reduces to 3, reduces to 2, and finally to 1. Y increases from 1, goes to 2, goes to 3, and goes to 4. So from this, we will now be able to use the Pascal triangle to expand our binomial. Note that since we have generated the Pascal triangle, you don't need to do that every time you are expanding. So it is available in your mathematical tables. If you check, you'll be able to see the binomial expansion, which we refer to as Pascal triangle. So you just check the coefficients, the expansion, the index, you note, then you go to your Pascal table, check the coefficient, and also note the change in indices or powers of the variables, and then you should be able to expand a binomial. So we are going to take an example and see how we can make application of this knowledge. In this example, we are supposed to expand this. So if you don't have a mathematical table, you can generate the Pascal triangle. So let me do that for now. So we have 1, we have 1, we have 1, we have 2, 1, we have 1, 3, 3, 1. This is when it is 0. We have 1, 2, 3, then we have 1, we have 4, 6, 4, 1. Then so this is when it is, the index is 4. When it is 5, it will start with 1, 5, 10, 10, 5, and 1. So these are the coefficients. So to expand this, I can say it is equals to x, we start with x, so x will take the power of 5, that is index 5, plus the next coefficient is 5, so we have 5, x reduces by 1, so we have x to power 4, and y increases by 1. The next coefficient is 10, so we have 10, x decreases by 1, so we have x cubed, and y increases by 2, by 1, so we have y squared. So we have the next coefficient is 10, which is x reduces by 1, you have x squared, y increases by 1, we have y cubed, plus the next coefficient is 5, x decreases by 1, so we have x power 1, y increases by 1, we have y to power 4, and finally x goes to 0 and y increases to 5. So that is the expansion. So we can write it again here and say this is how it looks like. So we now have x to power 5 plus 5x to power 4 y plus 10 x to power 3 y squared plus 10, we have x to power 2 y cubed plus 5x y to power 4, and finally plus y to power 5. So that is the expansion that you get. Remember, I've said it's not a must that you generate the Pascal triangle. You just read the coefficient from the Pascal triangle or from Pascal table, and then you just substitute. So in our next example, we will not generate the Pascal, but we just simply read the coefficient from the table. We will combine now. We put our coefficient, and this will give us. What we have here is so we have the first coefficient is 1, so we say it is 1 multiplied by 16 a to power 4. Then the next coefficient is 4, so we say 4 multiplied by 24, then we have a cubed b. The next coefficient is 6, so we have so this is supposed to be plus, so that is plus. We are now expanding, so we have 6 multiplied by 36 a squared b squared, then we have plus. The next coefficient is 4, so we have 4 multiplied by 54 a b cubed, then we have plus. The next coefficient is 1, we multiply by 81 b to power 4. Now when we now multiply 1 multiplied by 16, we will remain 16. So we have 16 a to power 4 plus 24 multiplied by 4, we will get 96, so we have 96. We have a cubed and b, then we have 6 multiplied by 36, we will have 216, a squared b squared plus 4 multiplied by 54, you get 216. We have a b cubed, and finally we have 1 multiplied by 81, you get 81 b to power 4, and that is the expansion of our binomial there. That is 2a plus 3b raised to power 4. In this example, you expand x minus y into bracket raised to power 5. So the coefficients are 1, 5, 10, 10, 5, and 1. So when we expand, then we have x minus y into bracket raised to power 5 is equals to, so we start with x raised to power 5 plus 5, the next coefficient 5, x raised to power 4, and we have minus y, put the bracket, then we have plus 10, x raised to power 3 minus y squared, then we have plus 10, 10, x raised to power 2 minus y raised to power 3, then we have plus 5 x minus y raised to power 4, and finally we have plus minus y raised to power 5. So note here, when you add the powers of the terms, for example here y 5, 4 plus 1 you get 5, 3 plus 2 you get 5, 2 plus 3 5, 1 plus 4 5, and finally 5. So the total of the indices should be 5. Now we expand. Now we say this is equals to x raised to power 5. Now this is minus y, so minus y raised to power 1 will give us a minus sign. So here we have a minus 5 x to power 4 y. Then here we have minus y squared. So when you square minus y, you get positive. So we have plus 10 x to power 3, and we have y squared. This is y cubed. So when you cube minus y, you end up with minus y cubed. So our term will be minus 10 x squared y cubed. Here we have minus y to power 4, so it will be plus y to power 4, so we end up with 5x y to power 4. Then minus y to power 5 will be minus y to power 5. So note that when we have one of the term is negative, then the signs keep on alternating. That is, from alternating here means here we have negative, here we have positive, negative, positive, negative. So when one of the term is negative, the sign keep on alternating from negative, positive, or positive to negative. So get answers for the given exercise from Teacher Wamtaa YouTube channel. It is important you open a Gmail email account, like and subscribe Teacher Wamtaa channel so that you get all the lessons and revision questions that I have prepared. If you don't know how to open a Gmail account, you can get assistance from Cyber. Or if you know how to browse the internet, you can just go to www.google.com. Then you find an option of opening an email account. If you don't have one, you can use one. If you are a student, use your parents' account. You will be able to access these materials.